good morning, good afternoon, or good evening. I hope everybody can hear me. Confirmation from Edouard and Julien?
Yes.
Yes.
Excellent. Okay, well, thank you very much for joining us today with this webinar. I see that there's quite a lot of people already connected, so I don't think we're going to wait around for anyone else to connect. I think we'll get stuck into it straight away. I'm Virginia Lapierre. I work with Roctool. I'm in charge of communications and events here. Today, we will be showing you a live demonstration. And prior to that, Edward Phillip from Roctool, who looks after our composite processing, he will be speaking about Roctool and then about LIT technology process. Following Edward will be Julien Rion, who we're very happy to have with us today, and he's from the company Bcomp, and we'll be using Bcomp's material today in our live demonstration also. Just a couple of things to point out to you regarding BlueJeans. I don't know if you've used this platform before, but you'll see that there's some settings, usually on the right-hand side of your screen. That's where you'll see when there might, if you want to send a chat. I'll be sending a couple of polls during the event. So if you see something pop up on the side, feel free to answer. And if there's anything else you want to speak to me about during the webinar, send a chat and I'll answer you from there. Okay, well, I think we'll pass over now to Edward, who will take the presentation. Thank you very much.
Thank you, Virginia. Thank you for your introduction. Thanks also for the collaboration of Bcomp company for this new composite webinar at Roctool about sustainable lightweighting application. The focus of this webinar is also to have, at the end of this presentation, a live demonstration with our LIT process using bio-based material and especially Bcomp material with flax fibers. So first of all, a few words about Roctool. We are a leading heat and cool technology using for composite and plastic injection molding. We integrate induction heating inside tool to have a fast heating on the mold surface, and we combine this technology with a cooling process to have a full package to transform composite material with benefits to reduce the cycle time. All these processes are integrated in a conventional press for all manufacturers. What exactly is the heat and cool technology? The name of the technology is 3i-Tech. In fact, we integrate induction system inside the tool near the molding surface, and we use induction heating to heat the mold surface and to transform composite material. We combine also water system to have a cooling system very efficient to transform material. You see here thermal simulation we made engineering study where we define the size and the design of the integration of induction inside tool to transform material. On the right, you have the principle of induction heating. In fact, we use inductor cable integrated inside the magnetic tool, and with the Roctool component, like induction generators, we use the AC current inside the inductor coil, and this AC current creates a magnetic field. It's just 1 millimeter just around the inductor coils inside the tool, and this magnetic field induces an opposite current. We create a heat, and like that, we have a heat diffusion to mold surface with a very fine control of temperatures and a very efficient technology. Few history about Roctool. Roctool was created in 2000 at the beginning in the composite market, and of course, in this year, it's mainly about thermostat application. Now, The LIT process where we focus today this webinar was started in 2016, and the first LIT system sold was made in 2018 in Korea. Roctool have the headquarters in France, but we have also another office in China and another one in US. So Roctool, we are technology providers. What we offer exactly? We offer the engineering study to define the integration of induction heating and cooling system inside the tool. So for that, we have an engineering department. We are full focus about heat and cool technology. We supply also tool components. It's mainly inductors, which are integrated inside the tool in relation with wall makers. We supply, of course, Roctool equipment, which is mainly induction generators, with a large range of induction generators from 25 kilowatt to 300 kilowatt of power capacity. With these induction generators, we have other full package equipment like a cooling unit dedicated for the process. And our last offer is all the installation, process startup, and training all of the equipment all around the world. Now, this year, we have more than 350 system installation all in the world and in different markets like aerospace, automotive, electronics, and sport and leisure, for example. What is the benefit of the Roctool technology? And why we think it's a sustainable technology? We think that it's not only to have a bio-based material. We need to mix also with a very efficient technology, very efficient process to transform composite parts. And with a combination of material and process, we can challenge and give the best to transform composite parts. So today, we for this webinar, we make a focus about the specific technology we develop, which is the LIT, combined with bio-based material. On this slide, you have some example of current composite parts we make with Roctool technology. On the left, you have a view of a laptop cover when you can reach A-class surface finishing with our technology. It's for electronics market. In the middle, you have some example of automotive exterior parts. It's a thermoplastic composite parts with carbon fibers to have a high surface quality, to reduce the weight of the product, and also for a technical point due to the airflow of the integration of this composite part in the wheel and to reduce the consumption of the car. On the right, we have also an example of a current application with a design chair produced by Revology, which is also a partner of Roctool, made with bioresin and flax fibers. And the interest to use Roctool in this application is to have a very temperature control to limit the thermal degradation of the natural fibers. Now, just to explain why we think Roctool is sustainability process. It's because we can elevate the final product with our process and we adapt the process in relation with the material. So, for example, we can transform recycled carbon fibers like scraps in new material with a very good quality and very nice finishing surface. In the middle, you have also a view of natural fibers composite parts, where for the reason of the interest of the Roctool due to the thermal control of temperature, we can do this part. And on the right, you have another example where we use reclaimed clothing to do another life of waste material. So the interest also of Roctool technology is to reduce secondary operation like paint and to produce net shape parts. Now I move on the explanation about the ILIT process. Of course, the interest of this webinar is to have this live demonstration at the end of this presentation and to show you live correctly the process. Two key points about this technology. One is we developed this technology to have a new process, an innovative process to be out of autoclave and out of press. For that, we developed a very thin shell of tool with interest to have a best cycle time compared for conventional process. So for that, we designed the integration of induction heating and cooling channel inside a very thin shell to have a very fast heating. Second point of this technology is that we use a flexible membrane on the top of the process to use like consolidation of the product during the cycle. We do this because we would like to use this technology to produce large parts with a very low energy consumption. This process is very flexible, so we can use with thermoset material or thermoplastic, and there are no limitations today with this technology. So now some details about the technology LIT, or light induction tooling. The first principle, you are here a sketch. We show you the concept. We use a heat and cool tool. In this case, it's a flat tool, but this technology is also very interesting to use in 3D geometry parts because we have on the top of the process, you are here in the green line, which is a flexible membrane, like a silicone membrane. We use to consolidate the material with a system to apply air pressure on the top of this silicone membrane. And it's why like that, it's comparable like autoclave process because we can apply isobar pressure all around the molding surface of the parts. Of course, all this concept is integrated in a specific structure frame to have a full system completely autonomous. The interest also of the LIT process is a very custom integration. So we can define different tools materials in relation with the thermoplastic resin we use. So for example, if we use thermoset, we can take Invar alloys, and if you would like to transform high performance thermoplastic material like PIC resin, we need to use steel alloy with a specific magnetic steel to have a best efficient of the induction heating technology and the best reactivity with our technology, and in this case to use at up to 400 degrees. In relation with the tools materials, can define the tool dimension. It's why also this process is really interesting because we can produce a very large part, more than 1, 2, 3, 4, 10 square meters. And in relation with this dimension, we can adapt different multiple generators and to be able to have multiple zone of heating. On this slide, I put some information about heat and cool performance concerning the process. So on the first picture, you have a view of what we deliver with our engineering study about thermal simulation. After to have defined the integration of induction heating, we do a thermal simulation to define the homogeneity of the temperature on the molding surface. Here, it's the case for thermal cycle from 70 degrees to 240 degrees. We can reach a heating time less than 1 minute and a cooling time very efficient, less than 20 seconds. of course, the holding time is also in relation with the material we use in the process. Of course, we check this thermal homogeneity. Globally, we can target plus or minus 5 degrees, depending the shape of the tool, of course. And so we check the homogeneity of the temperature after the installation of the equipment, where we fix thermocouple on the surface of the tool, and with thermal camera, we check that we have the same target like the thermal simulation. Now, to finish my presentation, you see here what we refer like a complete solution for composite at Roctool. So in the middle, you have the frame of the LIT cells, and in relation with the Roctool equipment like generators, cooling unit, and interface controller. But I make this focus during the live demonstration, and it's better to see in live all the equipment. So just before to conclude, you are here a view of our installation at Roctool headquarters in France. So we are a tool of quarter of car hood with this dimension. We can use different thickness of material, a very wide range of material, from carbon fibers, non-woven fabrics, glass fibers, and of course, bio-based material. For this demonstration, we target the cycle time of 3 minutes at a temperature of 200 degrees and a air pressure of 6 bar. But now, Julien Rion presents the Bcomp company, and after that, it's a pleasure for me to present the live demonstration. Thank you for your attention.
Hello, I hope everybody hear me and you see my screen for the presentation. So thank you, Edward. Thank you. So thank you for the introduction, and I'm very glad to give this part of the presentation within this webinar today about what we are doing at Bcomp. So Bcomp, we are specialized in natural fiber composite solutions, and I will describe our solutions and in our different markets, and then with a special focus on our thermoplastic solutions, which are likely to be processed with LIT technology. We will see after in live. So at Bcomp, just about the history. So we are quite not so young anymore company, but we still like to say young company. So 10 years old company. When we founded the company, we really focused firstly on sports and leisure industry to introduce our new natural fiber composite in the market, because it's short time to market in that field. And then we had this good transition to motorsports industry, where we have solutions which are very well adapted to those markets. And finally, now we are entering large-scale mobility market, large-scale industry, where we use more thermoplastic, and then with solutions that we will see today completely make sense. So what are we selling at Bcomp? We are firstly selling lightweight, high-performance, sustainable material. So we always focus on application where we can add performance. So our product, so we are not farmers, we are not part makers, we are just selling the material to make parts. So we are buying and then developing the yarn we need with partners. And then from this yarn, specially developed for our composite application, we make the good reinforcement needed for our partners who are making the end parts for example, here we see a door of a GT car, which was made with our Amplitex and Power Ribs. So what is the target when using those materials? So mainly it's weight reduction. It can be up to 50 weight reduction in certain applications. We'll see some examples. Or it could be cost efficiency, so it's also it doesn't come first in argumentation, but clearly the lower eco footprint is also the main message with our sustainable material. So here we see different applications and what are the advantage of our product in those applications. So clearly in sports and leisure, we, for example, in ski industry, target a lighter weight, and that's why a lot of people are using our V-cores for making the ski and our reinforcement to save up to 30% weight or decrease the eco footprint by 75% compared to carbon fibers. In motorsports industry, where our products are very well applied for car body, we can save a lot of cost compared to carbon fibers with equivalent performance, and so to 30% reduction, and we have a lower eco footprint, again 75% compared to carbon fibers. And then when we go to large scale mobility, clearly here the door opener is that we have solution which can save up to 50% of weight, and again we have much lower eco footprint compared to actual materials. So what are our products? We have three different categories. Our first category is our products range is Amplitex. It's our range of, I would say, standard flax composite fabrics. So we have woven fabric, we have biaxial fabric, we have UD fabric, all made with flax, but with structure which you could find similarly with carbon or glass fibers. So clearly it's kind of mimicking what is in the standard market with synthetic fibers, but with natural fibers, and so optimizing the performance of the natural fibers for this use. Then we have another product, which is the Power Ribs product, which is a green reinforcement. I will give more details on the next slide on this product, which is a key for our technology. And finally, the B-cores, which is more core reinforcement, mostly used in sports and leisure industry and especially skis, which is not a focus today. So the Power Ribs clearly is for us an enabler for natural fiber composite. This product is actually a grid-like structure, as you see on the left image, where and this grid-like structure is laid on the top surface of your part, the non-visible part, and then when molded with classical molded technology, so it could be for thermoset using autoclave, vacuum infusion, or with thermoplast could be compression molding with a silicone stamp on that side, or as we will see today, the light induction tooling with a soft membrane on that side. So with this conventional molding technology, then you get one side with a ribbed structure and the other side with a class A surface. And this ribbed structure increase a lot the bending stiffness without increasing too much the weight. And this so clearly enables the use of natural fiber composite in much more application, for example, for motorsport car body structure, where it would be difficult without this technology to be competitive with the existing material. So we have spent a lot of time optimizing the architecture of the grid, the architecture of the yarns used for the grid to take the best properties possible out of this technology. So a few example of application of our products in sports and leisure. First, you can see that it's used in a wide range of application, from longboard to skis, so more and more so in naval industry, kayaks, bicycles, so also ski poles, surfboards. So there is a large range where it could be for lightweighting, for vibration damping increase, or for more sustainable message. So there are many different cases in that field. One of our very important markets is, as mentioned before, the motorsports. A clear reason for that is so there is a lot of use of carbon fibers in that market, and clearly it's very well so our porribs technology very well applied to this market, which is mainly thin shells, so for the car body, and the porribs is exactly spot on for thin shell technologies. So in that case, we'll focus on, for motorsports, on porribs using thermoset matrix, so epoxy matrix or other thermoset resin to have the highest performance possible. And so the layup which will be used could be a full natural fiber layup, like we see here. So combining some layers of Amplitex plus a layer of porribs, and then impregnated with typically with an epoxy and in an autoclave. And with such a layup, you can replace carbon fiber layup with equivalent bending stiffness. So you can match the performance for a car body structure. Of course, you decrease the environmental footprint by 75%, as I already said. Very good advantage too in that field is improved safety. Not that it's not stronger than carbon, it will break, but when it breaks, it doesn't explode into multiple debris like carbon fiber will do. So it's much safer crash behavior. And of course, so compared to carbon fibers, there is a very much improved cost efficiency. One of the nice application we have seen recently and was communicating by our partner McLaren is the McLaren seat. So for its first application of natural fibers in Formula One, so they built a seat using our materials and porribs. And so clearly here the advantage is it's an improved vibration damping compared to carbon fiber version. And of course, so lower material cost, lower eco footprint, and you don't have this brittle fracture in case of shock. Then from motorsports, clearly we aim to apply our technology to much bigger market, and we go then in large scale mobility, where we are not working anymore with thermoset matrices, but with thermoplast matrix. And clearly our products are also well, let's say, well made for being processed with thermoplast matrices. And also the porribs we have a version already pre-impregnated with polypropylene for this large scale sector. So typically in those applications, it's again, we are aiming of making internal parts in automotive. So like we see here, it's a seat back of the Polestar Precept, which the collaboration was announced this year. So where we could save up to 50% of weight compared to the injection molding plastic. So decrease a lot the plastic contents and have then almost half eco footprint compared to the plastic version. So how we make the part? It's the base of the structure is a combination of our porribs, which is a key to have the performance we want. So the weight decrease, and decreasing the weight and material also then decrease the CO2 footprint. And we combine it with a natural fiber mat, which is a standard material already in automotive, but we use a much lighter mat because we have the porribs. And we can process it in a standard processing the compression molding process for automotive in cycle time up to 1 minute. And so this is a typical layup which could be used. So as I said, so the core is the porribs. So in that case, impregnated with thermoplastic, so polypropylene. Then we have a natural fiber mat. And then we can have different decorative layers. So standard one that you would find in automotive like laser, cork, textile, Alcantara, or we could also use our Amplitex as structural and decorative layer at the same time. Another advantage is we could use one-step process also injected injecting the fixture point on the backside of the part within the compression molding step. So this is standard in automotive process, and this could work also with our materials. We have made a demonstrator, and this was tested. And the applications are almost all indoor parts, so trim parts inside the car. So these are the main advantage, as I said before. I will not go into detail. So clearly, compared to injection molding PP, a lot of weight saving. And so here is the weight saving, and the global CO2 footprint reduced a lot compared to such application. So as mentioned, with our technology, we can be the skeleton for making a part which is then covered with standard material like carpet, textile, or leather. But also, and that's what we'll see today, we can put a decorative layer using our Amplitex on the top material. So the advantage is that you have at the same time the design layer and at the same time a structural layer. So you further save weight by just not adding weight by putting a decorative layer. And for that, we developed a thermoplastic version of our Amplitex, so pre-impregnated with thermoplastic for automotive and to now, and mainly with PP, but it's clearly also feasible with other thermoplastic like PLA, PA11, and so on. We could have various weaves and colors for the textile, so which gives at the same time nice design options for the structural material to be used. It's not like carbon fiber, which is black or black. Here you have a lot of different versions. And so you can use compression molding, as I stated before, but clearly one advantage of using the LIT technology we'll see today is that you can mold much more complex shapes due to the to this membrane process. So you can mold also very low draft angles. So this could be possible. And as you are melting some material in the tool, you can increase also the surface quality of the end part. So we'll see in just in a few minutes a live demo which show a combination of those materials. So we have on the top material an Amplitex layer with a so it's our 50-40 fabric. So it's a 300 grams flax fiber pre-impregnated with polypropylene, so 600 grams total. We have a natural fiber mat in between, so 700 grams mat, and we have our pour ribs, which is made also with flax and polypropylene, with a weight of pour ribs about 400 grams per square meter. So we'll see now live this material in the live demo. Thank you for your attention.
Thank you very much, Julien, for your presentation. Just before we go to the live demo, there's quite a few questions that have come in. So if you wouldn't mind, we'll just quickly skip to the questions. From Barbara, regarding Roctool technologies, what are the size limitations? What is the thermal homogeneity achievable for complex and large parts? She's asking about different types of technology, 3 to 4 meter possible. What do you think, Edward?
Yes. Do you hear me, Virginia? It's fine? Okay.
No? You didn't hear my question?
Yes, I hear your question.
Okay. Yeah. Sorry.
So, no problem. With the LIT technology, why we define our no limitation in dimension? It's because due to the design of the tool, and we would like to have a very thin shell to hit, we can use a very lower energy consumption for large parts, and like it's out of autoclave and out of press process, we have no limitation for example, dimension of platen. So for each application, we have the possibility to design the process in relation with your specification. All the target of thermal homogeneity is defined in relation with the integration of induction heating and cooling channel inside the tool. So it's this part is 2D during the engineering and during our thermal simulation to define the best position of the integration of induction heating in relation with the cycle and the thermal homogeneity. So globally, with this technology, we can target conventional that it's plus or minus 5 degrees.
Okay, thank you very much. Just a quick question for you, Julien, and then we'll go to the live demo. Do you have comparative material properties data versus glass carbon fibers?
Yes, we have. So compared to glass and carbon fiber, so I would say just in few words, compared to glass, we have about the same Young's modulus. So for composite, so thermoset composite, we have typical modulus for UD composite with flax, which is about 32, 33. So comparable to glass. The advantage is clearly that we have a lower weight, so the density of flax is 1.4 compared to 2.6 for glass. Of course, carbon fibers has a better in-plane modulus, so it depends on the choice of fibers, but the composite can be 200 gigapascal for a UD, which is much more compared to flax. But then a good advantage again is the lower density of flax, and that's why we focus on shell application, because there's density is a key, so that for a given weight you have the higher thickness of shell and the higher stiffness, and it's also multiplied with our pore ribs technology, so that's why we could compete carbon in thin shell application with our pore ribs, even if the stiffness of flax fiber is still about a quarter of the stiffness of carbon fibers.
Okay, thank you once again, Julien. We'll just go to our quick video before we go to the live demo. Over to you, Edouard.
Yes, welcome to the live demonstration. Now we are located at Roctool headquarters in France on our technical center, where we are all the installation about injection molding and compression molding technology. So now, just near me, we have the LIT cell, and I would like just to make a focus about the different equipment you are here, and you see here the example of demonstrator tool we can use for different development, and with a raw material supplier and with a tier one to develop innovative new composite parts. So first of all, just a quick view about the material we use for this demonstration. So you see here the what Julien before this during this presentation he described. We have an Amplitex material. It's a flax fiber prepregged with polypropylene. We use natural fiber mat and the power rib impregnated with polypropylene. So during this demonstration, we use this three layer to consolidate the material and to give a final composite part. Before to start the demonstration, I would like also to make an overview about the Roctool equipment we are here. So to start, the first equipment here is induction generators. So it's here in this case we use a double zone induction generators with a capacity of 200 kilowatts. So it's in relation, in connection with the tool you see here. And we have also a generator cooling unit. In this case, it's R30. It's used to cool some components installed inside the induction generators. So the interest also of this range of generators is that it's double zone generators. So it's like if you have two generators in one. And like that, you can manage different area on the same side of the tool to range different power at different parts of the side of the tool. So you are see the layout of the material, the tool, and the electric connection, and it's why we have two connections here. On the right of these cells, we are the interface controller. So you see here, it's the this process system. We can manage and set up all the process. We can manage, of course, the heating, holding, and cooling ramp with the indication of the power we set up in the process. We have the information about temperature and time, of course. On the right of the cell, we have the mold cooling unit. We use it, of course, to cool the tool during the cycle. You are here a global view of the LIT cell with the demonstrator tool we use with this process. It's a quarter car hood. So you can see the very thin metal tool to have a very efficient heating time. And on the top, you can see the flexible membrane and all the different to look the tool. But I explain that during the demonstration. So now we start the process with Guillaume, my colleague. We start the process. So we start the closing of the tool. You see the bottom of the tool. In this case, we move. Now we have a system to lock the tool inside in relation with the top of the tool. And now we apply air pressure on the top of the tool to consolidate the material. So just a quick view, we start the heating. So you can see it, the power we use for this cycle. So we are on the first generator, 33 kilowatt, and on the second, we use 42 kilowatt. I repeat that the capacity of all this range of induction generators is 200 kilowatt. So it's double 100 kilowatt in fact. So just also a quick view of the cycle. So we in this case we reach the 200 degrees in less than 1 minute and 20 seconds. We have an holding time around 1 minute due to we use bio-based materials. So and we use a 3-layer with this material, with the Bcomp material. So we need time to have heat diffusion through the 3-layer of material to have a good impregnation and good consolidation of the material. So I repeat.
Sorry, excuse me, Edouard. We've got a quick question. How many cycles will the flexible membrane last?
Yeah, it's a right question. It depends, of course, the temperature. with this conventional silicon membrane, we can work with up to 250 degrees. But we can use it with many thousand cycle with only one silicon membrane if we work with thermoset resin, for example. In this case, with thermoplastic, it depends on the temperature and, of course, the resin you transform. Now we start the cooling step. So you see here, it's a very fast cooling. In less than 30 seconds, we go to 200 degrees from 50 degrees. And now we open the LIT cell and we can demold the part. So Guillaume, here you see that we have a good consolidation of parts. You see here on the tool surface, we have a very glossy aspect with a high surface quality. You see here that like we use natural fibers, the aspect and the color of this material. It's really homogeneous. And you can see on the other side, the power reeds, we are integrated inside the composite. And with this possibility, we can obtain a really good rigidity of the composite part. So I think you have probably some questions after this live demonstration, and Julien and me are very pleasure to answer. Thank you.
Excellent. Thank you very much, Edouard and Guillaume, for the live demonstration. There are a lot of questions. First of all, I'll go to the last one that's come in. Edouard, if you could reply to this. What are the limitations on the depth or profile height of the part and how much the membrane can stretch?
Any case is possible. I think with this technology, for example, we can produce a 3D geometry part with a deep of more than 200 millimeters for an existing current application in language, for example, where we have a very important deformability of the product. Of course, we need also use in this case a good drapability of material to be able to follow the shape of the 3D geometry part.
Thank you. Are there examples of using flax fiber composites in the bicycle industry? If so, what are the limitations?
So maybe I take that one. So there are few examples of flax in the bicycle industry. So the pure flax fibers is mainly small projects in a very small series. There are some larger projects where it was a mix of carbon and flax fibers. It's more, let's say, to increase the comfort. Because as I mentioned before, carbon fibers is in plane stiffness is much higher than flax. So for making a bicycle frame, it's really the in plane stiffness which counts. So it's difficult to clearly replace carbon fibers. So you could make a complete flax fiber bike, but it will be heavier than a carbon fiber bike. So now the application we see, it's more a mix of carbon fibers and flax fibers. And there are few brands who are, so there was one brand who use it in a small series, and there are few brands testing it, I think, which comes hopefully in future with more flax. It's also because I think let's say the industry of bicycles, they have reached their limit with carbon fibers. They can make a so light bicycle. They have to find something next, and clearly the next thing is also more comfort for the user, also with the electric bike. So clearly here there is an opportunity of integrating flax fiber mixed with carbon to increase damping and comfort.
Thank you very much. A question regarding recycling. How can we recycle these parts? I guess this can go out to both of you.
Yeah, maybe I can begin for the material side. So recycling is always a very good topic for all composites. So here, this part, it's only flax fibers and polypropylene. So in theory, you can grind it down and use it as a charge for injection pellets. So this works. It's not only theory, it works. You can make an injection material with that by grinding it down. Then it's true that it's not an existing logistics chain right now. So this has to be built up so that people are really using that material, and there are things to develop. So it's feasible, but it has still to be, let's say, to become mature.
Okay, thank you. We've got a lot of questions coming in. I don't know if we'll be able to answer everybody during the hour because we've got another 8 minutes. We'll see how we go. I would like to ask, how much do they think that humidity in the natural fibers could be a problem? Also, the variance due to the different production zones.
So for that topic, for the variance for production zones, so this is very well mastered because flax fibers has a huge history for making, let's say, good quality flax even for a very bad year. So they are really used to mix different crops from different regions, to mix different year even, to have a constant quality of the fibers. And also a good thing, when a year is bad and the flax is a bit too short, this will maybe affect the strength of a dry yarn, but as soon as it's impregnated in a composite, it will not really change the property. So we can kind of guarantee a very constant quality over years and over different areas by the good selection of the mix. And then the effect of humidity, it's clearly a topic for natural fibers, which are hydrophilic. So you have to have a good protection against humidity. So for example, for interior part of a car, it's not so much a problem. When it's well impregnated, it passes the requirement for automotive interior. But if you want to build exterior parts like we do in motorsports, again, in motorsports, it's not a problem because it has to last for few seasons of races. Then if you want an external car body for a car which has to stay outside for 20 years, you really have to have a good coating to protect the fibers against moisture.
Once again, thank you. Edouard, what are the limitations in terms of drapability and geometry?
Yeah, do you hear me, Virginia?
Absolutely.
Okay, fine. Technically, we have no limitation in dimension. Like I explained, we can adapt in series different range of induction generators to manage a big area of composite parts. Due to the geometry, we need, why also I explained, we need to use also the best material in relation with the geometry of the tool and geometry of the part. In this case, we can use SRPP material, for example, like or another 3D semi-finished product with a good drapability to be able to produce this example of composite part. So finally, I think it's of course again a combination of the design of the technology and also the possibility to use the good raw material, the good reinforcement in relation with the application. But concerning the integration of induction heating, we can do what we want because it's the inductor are the flexible cable. So we can have 3D geometry parts, and we use the inductor cable to follow the shape of the part and to have the best efficient all around the mold surface.
Thank you once again. Quick question, if we can try to keep the answers a little bit brief because we're running out of time. And we can always contact you after the event, obviously, and speak with you individually. Have you pre-dried the material? Is a question from Martin.
So maybe I let Edward answer for the process, but for impregnation, we pre-dry the material before pre-impregnated the fabric. It's very important to get a good impregnation.
Yeah, and during this demonstration, we are now creating the material. Here we are at room temperature at our technical center, and I think due to we have the good quality of semi-finished product, in this case, we are no need to have a creating step.
Okay, thank you very much. Now we're having more and more questions coming in, which is fantastic. However, I don't know if we'll be able to get to answer everybody. All right, one moment. Okay, this is a question for Edouard that's going to be a little tricky one to answer in about 2 minutes, but what are the costs of a Roctool system shown in the demonstration?
Yes, of course, it's not easy to answer this question now, but I can just explain that to have a complete solution like we propose with LIT, we have different costs. We have the cost for the Roctool equipment, like I described at the beginning of the live demonstration, with all the induction generators and all the cooling unit and interface controller. And of course, all this equipment is have a cost in relation with your specification and what you would like to transform. If it's a large part, and in relation with the power capacity you need to use. Concerning the LIT process, it's in fact for each case we need to define a cost due to it's you know, in composite application you never have the same application. So each case is very specific, and for that we need to define the specific integration with a specific frame. We need to define also all the specification of the tool, because it's like I explained, it's a very important point. We need to have a very some study to define the good integration of induction heating for the tool, and also the good material for the tool, the choice of steel, of magnetic steel, if it's conventional steel or different. So for this reason, I can give you a global cost for this process, but I am open to exchange with you and to give you some current cost about our equipment, of course.
Thank you, Edward. I'd just like to say it's now 10 o'clock. There's no problem. We can continue answering questions, but for those of you who need to leave after the hour, you're more than welcome to disconnect. I will be sharing the presentation that we've been recording since the beginning. I will share that with you. I've had a lot of requests for that, so that will be sent to you either later today or tomorrow. We will continue, but for those who need to leave, thank you very much. Now, Edward, Julien. Are the ribs flat after processing?
No, it's really what we target. We after processing, we need to have the highest 3D aspect possible. so you gain the bending stiffness. So that's why we need, in that case, it works very well with the LIT process because we have a membrane. And if you can see show the other side also, Edward, so we can see that the pore ribs are not flattened. So we keep this 3D aspect of the ribs, which is very important to keep the mechanical properties. So that's why you need either a silicone stamp or a soft membrane in the tool to be able to keep this 3D aspect on this side of the part.
Okay, another one for you, Julien. Do you think Amplitex can be a material for thicker structural parts in automotive in the future?
I would say for thicker parts, so if we go to thicker structural parts, I like to say that with composite, in theory, everything is possible, but it's always a matter of cost and also a matter of clearly of performance. If you take, for example, the example of a chassis, it's not reasonable to make a chassis with flax fiber. So maybe some specific parts, but if you really need stiffness, finally, if you make it out of carbon, you'll be 4 times stiffer than flax. So you would have to put much more material with flax. So then you lose also the sustainability advantage by using more material. So, and again, so if you replace metals, clearly, or a lot of time processing costs are very important. So it's, I would say that it's not obvious limitation. It's feasible, but clearly the cost and sometimes the weight increase if we go to thick laminates compared to other carbon fiber composite or metallic parts could be let's say, could prevent to use this in a reasonable way.
Thank you very much. Another question regarding the flax fibers. How are they impregnated? With PP powder, PP film, or in an emulsion?
So we are working with both with powder and films. So it's not here using dispersion. So it's melt impregnated with powder and films.
Okay, thank you. On the Polestar part, it seems to have a transparency. We can see the power ribs. Is this the case? And is the photo in black and white, or is it possible to have a grey finishing?
Yes, it's possible to have a grey finishing. We have the fabric you have seen in the demonstration here, 5040 fabric. We have a charcoal version, so grey finishing. So this is possible. Then for the translucency, it will depend a lot of the matrix used. The matrix we see here on the photo is an epoxy matrix. We have another version with polypropylene matrix where it's a bit less translucent. So it depends. It's a taste of a bit a matter of taste. Clearly, you have better translucency with thermoset matrix due to better wettability of the fibers. But then, of course, it's not the same process time and cost. So this makes it a bit different using thermoset or thermoplast.
Thank you once again. This is a tricky question because we're doing a Roctool Bcomp webinar, but I'll ask it anyway. And I ask Edouard to reply first and maybe follow it up with Julien. Is it necessary to use the Roctool technology to achieve a high surface quality part based on Bcomp technology?
So who is starting? Edouard, you start.
Yes, of course. Yes, I hope we can increase and elevate the surface quality with the Roctool technology and Bcomp materials. What we can see is that with the induction heating, we can have a very good temperature control to transform this range of material and bio-based material. And due to also the fast heating, we limit the thermal degradability of the fibers. So probably it's an advantage comparable for the conventional process and to reduce the cycle time. And it's one advantage of the Roctool technology to due to we have a fast heating on the mold surface, we can obtain a very glossy surface on the material. It's why also we can see on the injection molding technology, and it's why Roctool is a lot of use in the beauty market, for example, or electronic application. So it's a really good point concerning Roctool technology, concerning the quality surface of final part.
Yeah, I can go clearly in that direction. So clearly, the advantage of the technology is to increase the quality of surface and also to increase, let's say, the possibility of molding at low draft angle. As I said, we could mold our material by classical compression molding steps. So just heating the material separately and putting it in a closed mold, just tempered mold and closing it and cooling it directly in the mold. But this do not work if you have, for example, very low draft angle. So it's very difficult to get pressure on the side if you have very low draft angle. So we clearly, with the LIT, by inflating the membrane, you can have this supplementary pressure. And also by clearly heating and cooling in the tool, you can get a better surface quality than with heating the material separately and put it in a cold tool and closing in the cold tools. And there is a much, let's say, faster and inhomogeneous cooling when you do like that, and it's difficult to get a good surface quality. It's possible in some case, but clearly the Roctool technology much open many doors for geometry and quality of surface in various geometries.
Wonderful. Thank you very much. I think we'll reply to these two last questions, and I think we've replied to everybody. So let's see. Assuming I am a manufacturer of motorcycle, I would need to integrate your technology for a large production. Would you say the price would be higher than plastic? And if so, what would the percentage be? My question is it adapted for mass market? Edward.
Yeah, already at this time, this technology is used for high volume market. It's like I said during my presentation, this technology was implemented in the consumer good application. So it's already the case. Of course, each case should be changed. And so I propose to contact Roctool to give you more information concerning this point also.
Okay, and the final question for this afternoon, depending where you are. How many LIT systems are currently in operation around the world? Obviously, we can't go into too much detail because we have confidentiality agreements in place, but I'm sure Edouard can give you a brief reply before we say goodbye.
Yes. So yes, we have several applications with the LIT process which are confidential, or also another in development. So I can give you that we are around between 5 to 10 complete LIT cells running now all around the world. And the first, like I said, it's installed in Korea on a technical center since 2019.
18.
19. Yes.
Okay, well, I think we'll leave it there for now. I would like to Thank you all very much. We've had a lot of people disconnect because we do state that it does go for 1 hour. But thank you very much. I hope you've enjoyed this event today. And we have another session this afternoon, but it's basically going to be the same. It's just to help different people in different time zones to be able to watch the webinar. Please don't hesitate to contact myself, Edouard, or Julien. You can see our email addresses on the screen. I will, as I said before, I will send you all the link to see this presentation again, probably tomorrow morning. Okay, well, thank you very much, and we look forward to presenting to you again. Thank you.
Thank you.
Thank you.
Goodbye.